Hi there, Mr. Sutton here, bringing you the IM3 4-7 classwork solutions on Min and Max Extra Practice. For this problem, we have a rectangular pen made with 100 meters of fencing. We want the greatest area of such an enclosure and the dimensions that give us that area. All right, well, let's draw a picture here. So here's our pen, and we have to pick the sides of this. The sides that I have control over. I've got control over maybe one of these sides, and then the amount of fencing I use on that side determines all these others. So I'm going to let this side be x. We have a distance of x here, and this side then is also going to be x. So what do I call these other two sides then if I'm using up x meters of fencing here? Well, if I'm using up 2x meters of fencing and I started with 100, that means there's 100 minus 2x meters of fencing for both of these sides combined. That means if I divide by 2, then there's going to be 50 minus x meters of fencing for each of these sides individually. All right, so now that we've got that settled, I got to have a formula here that I'm maximizing, the area formula. For a rectangle, that's length times width, which in this case is going to be 50 minus x times x. So I've got everything in terms of one variable now. And at this point, I know the max occurs at the vertex of a quadratic function like this one. Since this is intercept form, I'm just going to find the zeros and average them together. So we have zeros of 50 and 0. And the width, also the x value of the vertex, is going to just be equal then to the average of those. So 50 plus 0 over 2. So that's going to be 25, and our units here is meters. So if we have a width of 25, that means we're going to have a length of 50 minus this x value, 50 minus 25, which is also 25 meters. So we want a 25 by 25 rectangular pen to get the most area. Now that most area is just going to be length times width. Our length was 25. Multiply that by our width of 25, and that's going to be 625 square meters. On this one, we have a rocket launched vertically with a height given by this h function in terms of t, and they didn't give us any units on this, which is kind of interesting, so I guess we don't have to worry about units in our answers. All right, we want to know the max height attained by this rocket. Since we're trying to maximize a quadratic function, we need to figure out the basically the input and output value of the vertex. To find the vertex, since this is in standard form, I'll start with negative b over 2a. So I'll say the t value of the vertex, because there's no x's in this. T value is negative b over 2a. So this is the time the max happens at that we're trying to find. So this is going to be negative 80 for the b value over 2 times negative 16. And let me plug that in the calculator. So I'll use alpha y equals to set this up, fancy fraction. And that comes out to 5 over 2, which I could call 2.5 if I want. So that's 2.5 whatever time units we're dealing with here. And to figure out the actual height of the rocket, we just plug 2.5 back into this h function, basically finding the output value of the vertex. So that's going to be negative 16 times 2.5 squared, and all the rest of this with 2.5 plugged in for t. Let me use the calculator again for this part. So plugging all that in on the calculator, I end up with 110. And again, no time units, so that is just the answer. On this problem, we have a cost function for producing x units of radios, given by this c function right here. We want to know how many radios will produce the minimum cost and what that cost is. So if I'm trying to find the lowest value, the min value for a quadratic like this, that's going to happen at the vertex. So I need to find the x and the c value of the vertex. And since this is in standard form, I can use negative b over 2a to find the x value, the input value of that vertex. So that's going to be negative 12 over 2 times the a value 1, invisible 1 there next to the x squared. That's positive 12 over 2, which is 6. And since this is x, the units is going to be radios. So 6 radios. And to find what the minimum cost is, we just plug 6 back in for x in the c function. So 6 squared minus 12 times 6 plus the 72 there. And I could probably do this without a calculator. This is 36 minus 72 plus 72, so those actually cancel. And we're just left with 36, and that's in dollars. For this one, Angelina's average test score, y, at month x is given by this quadratic here. We want to know what month she achieves her best performance and what will the average be that month. So we're trying to maximize this quadratic, which means we need to find the input and output value of the vertex. And since this is already in vertex form, let's start by writing the vertex, which we can pick right out of here, and then we'll just use that to answer the question. So the x value of our vertex is whatever I'm subtracting from x inside this squared parentheses. Since I'm subtracting 7, that means the vertex value of the x is 7. And then the y value of the vertex is whatever I'm adding outside the squared parentheses. So that's 81 in this case. So now the input here, the x, this gives us the month at which Angelina gets her best test score average. So that's going to be 7 months at the time that this happens at. And then her actual score is given by the output value of the vertex, the 81 here. So that's 81 points for the y value of that vertex. For this problem, we have a 500-foot roll of fencing in a large field. We're constructing a rectangular playground. We want the dimensions of the largest such playground and that area. So let's draw a rectangle, because that's what we have to work with. And let me express each of these sides in terms of x so that I can start building a function to represent the area of this thing. So let me start by making this side here x, and this other side across from it must then also be x because it's a rectangle. They're the same length. These other two sides are a little trickier. So the key here is I've used up 2x feet of fencing already. That means I have 500 minus 2x left over for these other two sides. Well, if there's 500 minus 2x left over for both of these and I have to split it evenly, dividing 500 minus 2x by 2 gives me 250 minus 1x. So I have 250 minus x for this side, and then the same thing for this other side. All right, so the area in general of a rectangle is length times width. The length in this case we can call 250 minus x, and then our width we can call x. So now this is a quadratic, if you multiply this out, that I have to find the maximum value of. Now we know with quadratics, parabolas, the max value happens at the vertex. So we need to find the vertex. And since this is intercept form, I can find the vertex by just averaging the zeros together. So the 0 for this first factor is just going to be 250, because 250 minus 250 is 0. And then the other 0 for this other factor of x is just going to be 0. All right, so if I average these together, that is going to give me the x value of the vertex for this function. It's also going to give me the width of this rectangle. So I'm going to say width equals x value of the vertex equals 250 plus 0 over 2. Again, basically averaging the zeros together. Basically 250 over 2, that's going to be 125. That's going to be in units of feet for this problem. Now to find the length, because we also need that to know the area, the length is going to be 250 minus 125, which is going to be also 125 feet. So this ends up being a square that maximizes the area. And then the actual area is going to be our length of 125 times our width of 125, which I will do on the calculator now. So we have 125 times 125, or 125 squared you could have done. And that is 15,625, and that's in units of square feet. On this problem, owner of a ranch is enclosing a rectangular region with 140 feet of fencing. And to help the fencing cover more land, he's going to use his barn as one side. That's very crafty of this farmer to do, this rancher. So we want to know the max area the rancher can get by doing this, and then the dimensions of that region. Let's start by making a picture. So we just need a rectangle. And we know that one side of this rectangular pen is already the barn of the rancher. So we need to talk about the dimensions of the other sides here. So depending on what I make one of these sides, that's going to affect all of these other sides, because we only have 140 feet of fencing to work with. So I'm going to try expressing all of these in terms of x. Let's make this side here have a length of x. That means the other side across from it is also x. And then this third side is whatever's left over. Since we've already used up 2x between those two sides, that means we have the initial 140 feet of fencing minus 2x left over for this last side. And now that I've got all these expressed with one variable, I can start to make a function for the area. I need to make a function because that's what I'm trying to maximize, is basically the area function. So for a rectangle, area is length times width. Length in this case is going to be 140 minus 2x. Width is going to be x. And to maximize a quadratic like the one I see here, I need to find the vertex. To do that, since this is intercept form, I just have to average the zeros together. So the 0 for this first factor, basically 140 divided by 2 would give me 70. And then for this x, the other 0 here is going to be 0. So now the x value of the vertex, which will also give me the best width for this pen here, so those two things are going to give me the same thing. This is going to be 70 plus 0 over 2, basically averaging the zeros together. And then that's going to be 35 feet. So that's the width that our pen needs to be to maximize the area. Now let me also find the length. I need both dimensions. Length is going to be 140 minus 2 times the 35 that we just found for x. So that's 140 minus 70, which is also 70. So 70 feet. And now to find the area, I have to take my length of 70 times my width of 35, multiply those together, and let me do that on the calculator. So doing that on the calculator, I end up with 2,450, and that is going to be in units of square feet. For this problem, we have a formula for the height of a rocket, this h function here, and this is a function of time, t. We want to find the number of seconds to reach the max height and what that height is. So if we're trying to maximize a parabola, we need to find the vertex. To find the input value of the vertex, since this is just standard form, I can say the t value of the vertex is going to be negative b over 2a. That's my vertex formula for standard form. So this is going to be negative 96 over 2 times the a value here of negative 16. So that's negative 96 over negative 32, which is actually exactly 3. So that's kind of nice. 3 seconds is our units here. And now to find the number of feet for our max height, we just have to plug this 3 back into the h function, and that basically gives us the output value of the vertex, which we know on a parabola is going to be the highest value, at least if it's an upside-down parabola like this one is. So we plug 3 in for t in the h function, and let me see what that comes out to on the calculator. So crunching all those numbers on the calculator, I end up with 194, and that is units of feet. On this problem, we have the temperature of a school given by this function where T is in degrees Fahrenheit and H is the number of hours. We want to know the hottest time of day and the temperature at that time. So we're trying to maximize a quadratic function in vertex form, parabola vertex form, and we know that the max and min always happen at the vertex. So let's write down the vertex first. So that's going to be 4.5, whatever's being subtracted from the input inside this squared parentheses. That's the input value of our vertex. So 4.5, comma, 76. Whatever's being added out here outside the squared parentheses, that's the output value of our vertex, the y value. So now the hottest time of day is going to be this input value of 4.5, so that's 4.5 hours. And the actual temperature is going to be the output value of the vertex, which is 76 degrees Fahrenheit. On this problem, the likelihood of getting sunburned, b, as a percentage is given by this b function, which is a function of t, time. And time is number of hours after noon. So that'll be important when we're trying to figure out at what time we have the least chance of getting sunburned, and also what that chance is. So we're essentially, if we're trying to find the least chance of getting sunburned, we're trying to find the smallest value of b in this function, which is to say we're trying to find the minimum value of a quadratic function. Since we're trying to find the smallest value of a parabola, we need to look at the vertex and see what the output value is there, which means I need to find the vertex in the first place. Now, the good news is that this is already in vertex form. So I can pick the vertex right out of here and then just get what I need out of that information. So the input value, the t value of the vertex, is whatever I'm subtracting from t inside this squared parentheses. Well, I'm not subtracting anything, right? I'm adding 10. But that really means I'm subtracting negative 10. So I have a vertex with negative 10 as the input. Now the output value of the vertex, the y value if you will, or the b value on this problem, is whatever you're adding outside the squared parentheses. So that's going to be a positive 15 here. Okay, so we have negative 10 as the input value. That's telling us the time at which we have the least chance of getting sunburned. So we have a time of negative 10 hours. But since so if we have negative 10 hours, that basically means since t represents hours after noon, this is saying 10 hours before noon is our least chance of getting sunburned. So that's going to end up being, let's see here, 12 minus 10 would give us 2 a.m. So if you want to go out on the beach at 2 in the morning, I guess, you have very little chance of getting sunburned. And the actual chance of getting sunburned is going to be the output of the vertex, this 15. So that's a 15% chance of getting sunburned. For this problem, a biologist's formula for predicting the number of impulses fired after a nerve is stimulated is given by this I function right here, where I is the number of impulses, x milliseconds after stimulation. We want to find the maximum possible number of impulses. Okay, so we need to find the time at which that happens and then plug that into this function. Since we're trying to basically maximize a quadratic function, we need to find the vertex. And since this is standard form of a quadratic, we can use negative b over 2a to find the x value of the vertex. So that's going to be negative 40 over 2 times the a value, negative 1. Since that's negative 40 over negative 2, that's going to be 20, and x is in units of milliseconds. So how many impulses do we get at 20 milliseconds? So just plug 20 back into the I function right here. That'll give you basically the I value of the vertex. And what's that going to come out to? Let me do this on the calculator, might as well. So plugging all that in and letting the calculator handle PEMDAS, we end up with 355, and that is impulses.